Hello guys, welcome back to my channel based on African motives. Still working on O-level maths. So in this platform we have got the question paper that we have from November 2017 session, so which I'll just quickly rush through and see what we're given in this platform. Is actually paper 1, 2 hours 30 minutes paper. So we shall quickly work this question paper together. Make sure that you read all the instructions and everything that you'll be given. It's for you to read those instructions. Okay, so not wasting much of our time, we are given the first part of the question here to express 99,987. That is what you're given in this case, this number, to one decimal place. That is the first part of the question, to one decimal place. So as we know, guys, to one decimal place, which means we actually need one digit after the comma in this case. So the next number that we have here is an 8, which can affect this 9 here, so that we can have a 10. And this 9 gives a 1 here. On this 9, it becomes a 10. It gives a 1 here, it becomes a 10. So that's what you're going to have. So to one decimal place, we are going to have 100, comma. Here, we are supposed to have 0, 0, 0 after the comma. But since we just did one digit after the comma, it is going to be 100, comma, 0. So that was the case in this part. Then on B, correct to one significant figure, that is 1 to 1 SF. We are supposed to have the first digit, which is a 9. So as you can see, this 9 is going to affect this 9 and it becomes a 10. And all these numbers, they become zeros, all these numbers after the comma. So we are just going to take 100. All these zeros after the comma, they are no longer important. Take note, if you're dealing with significant figures, these zeros, they won't be important. So that's what we had. Then in standard form, we have to make sure that our number in this case is in between 1 and 10. That is what is important in this case. All right, so what are we going to do in this case? Sorry for that, guys, I actually deleted everything, but let's just see. So we want to make sure that this number is between 1 and 10. So that means we are going to have 99,987. So between 1 and 10, we're just going to move the comma to the left. That is 1 comma to the left at this point, which is going to be 9, 9, 9 again. We've got 8, 7 times 10 to the power of 1. So the first digit is a significant digit, which means you're referring from numbers 1 to 9. When your number starts with these digits, it becomes positive, but whenever it starts with a 0, it becomes a negative power. All right, so that was it in standard form. Then it's just 3 marks for that. Okay, from the list of the numbers, write down the rational. Take note, guys, it's rational. Rational, these are numbers which are exact. These are exact numbers or exact values. The numbers that when you express them as decimals or whatever that you're going to express, they are going to give you exact values. Okay, so we refer to numbers such as 3, 1 is exact. Square root of 3, we do not know this one. We can't simplify this. That's an irrational number. An irrational number. Then we've got 0, 3, it's exact. All right, what is square root of 169? We know that square root of 169 is plus or minus 13, which means it's an exact value again. And as we can see, guys, here, if you had to express this as a decimal, it does not end. So, which means the irrational numbers, the rational numbers that we are given in this case, we are going to have what? 3, 1, 0, 3, and square root of 169. So that's what we had. Those are rational numbers. Then on number 3, simplify 2 plus x to the exponent of 0. So as you know, guys, anything to the exponent of 0 becomes what? Becomes a 1. Anything, a bracket. So if you're given bracket, but take note, if you are given something like this, yes, we are saying any number to the power of 0 gives us a 1. But if you are given something like this, minus 100 to the power of 0, this one, it gives you minus 1. It's different from something of this nature, minus 100 to the power of 0 like this. This one gives us a 1 because the whole bracket is raised to the power of 0. But this one, it is a 100 that is raised to the power of 0. So you get 1, then multiply by minus. All right. So that was it. Then simplify this case B. So as you can see, guys, 3 and 3 are common. So you can cancel, which means we are left with these 2. And as we can see, these are dividing. So what are you going to do? We subtract the exponent. This one is same as x to the exponent of 1. So you subtract minus 1 there, which is going to be x to the exponent of minus 3. Then from our laws of exponents, we know that x to the exponent of minus a is 1 over x to the exponent of a. So this is going to give us 1 over x to the exponent of 3. All right, so that's what you're going to have. As you can see in exact form, we are done. Then on number 4, we are given that is okay, and A, write down the special name given to triangle ABC. So let us cross-check our triangle ABC. As you can see, ABC, we are given an indication that this side, this side, this side are equal. So this is an equilateral triangle. So that one is an equilateral triangle. All sides are equal. So it's going to be an equilateral triangle. So that is what we were given in this case. All right. Then B, mark the angles marked P. Okay, calculate the angles marked P and the other one marked Q. All right, so let us start with the P. So as you can see, guys, this is an equilateral triangle and it's one of the angles in an equilateral triangle where we know that these three angles are the same or these three angles are equal. And we know that angles in a triangle, they add up to 180 degrees. So to find P, it is just going to be 180 degrees divided by 3 because all these three angles, they are equal. So it's going to be 60 degrees. So this angle is 60 degrees here. This angle is 60 degrees here. This angle is 60 degrees here. That is what it actually means. So that was the condition. So which means our angle P here is going to be 60 degrees. All right, what about angle Q? If you have to cross-check, this is a straight line, and the Q part is an exterior angle. So this one, we are going to simply subtract 60 from 180 because we are talking about angles on a straight line. So that is going to be 120 degrees. You subtract this, this is going to be 120 degrees. Okay, I think this one is just direct, which is 120 degrees there. All right, so that was our angle Q. Then let's see. Question 5, we are given that A, calculate the number of minutes between 1935 and midnight the same day. Okay, so this is 1935 and midnight, and we know that midnight of the same day, midnight is actually 0000, that is 1200 hours. So we are going to subtract 1935. Okay, so the first thing, if we are to subtract here, we're going to see that it's impossible for us to subtract 35 from 00. So you're going to borrow 1 hour here. That is going to be 23. And if we borrow that hour and write in minutes, it is going to be 60 minutes. All right, so if we are to subtract these two here, we are going to have 60 minus 35, which is 4 here, and 10 minus 5, which is 5, 6 minus 4, which is 2. So you're going to have 25, then 23 minus 19, which is 4. So this is actually 4 hours, 25 minutes. That is the time, but we are given to calculate the number of minutes, not hours. So we are supposed to convert 4 hours into minutes. And how do we convert 4 hours into minutes? We know that in an hour, we've got 60 minutes. We're going to multiply by 60 minutes, which is going to be 240. So it's going to give us 240 minutes in this case from 4 hours. So if 4 hours is 240 minutes, that means we are going to add 240 plus 25 minutes, because already this is in minutes, so that everything is going to be in minutes, and this is going to give us 265 minutes if I'm not mistaken there. All right, so make sure that you add properly. That's it. Then number 5B, express or write 75% as a common fraction in its lowest term. So as you can see, it's just a removing of percentage. And how do you remove percentage? You divide by 100. So that's how you simply indicate whenever you've got a percentage. That is going to be, all right, that is going to be what? By divide by 100%. So I just want to rewrite this properly, guys. All right, so this is 75% over 100. So it's going to be 75 over 100, just like that. So if we divide by 25 here, that is 3, divide by 100, which is 4. So that's it as a common fraction. If it was a decimal, then you write it as a decimal, but in this case, it was a common fraction, just like that. And On number 6a, you're asked to estimate the value of, this is the expression, by rounding off each number correct to one significant, just rounding off to one significant. That's the first thing. So to 1SF, this 7, we are going to check this 6. Is it going to affect this 7? Yes, it's going to give us 8. So it will be 8 times 5 here. We check 6. 8 is going to change 5 into 6. All right, times. We move on this 9. 3 cannot change this 9, so it's going to remain as a 9. Everything over, we have got a 2. This 7 is going to affect this 2 into a 3. So it's going to be 3, 0, because this 7 is going to change into a 0 and a 0. So it's going to be 30, 0, which is what? Which is 30. 3 here, this 1 cannot change this 3. So it is going to just remain as 3, which is 30 there. All right, then we can reduce as much as we can using the concept of your division by 6 here, that's 1. By 6 here, that's 5. By 3, that's 3 here. By 3 here, that's 10. And we can reduce here by 2. Here, that is going to be 4. By 2 here, that is going to be 5. So as we can see, we can no longer reduce here. So you can multiply the numerator to the numerator, which is 4 times 3, that is 12. 5 times 5, which is 25. So that's what you're going to have in this case. All right, so that's it as a common fraction by estimating and rounding off and so forth. So B, find the highest common factor between of these numbers 9 and 12. So guys, just imagine the type of question that they're asking us to find the highest common factor. So you just need 9 as a product of these prime factors. That's 3 into 9, 3, 3, 1 here. And we've got 12, which is 3 into 12, that is 4. We can start with 2. Yeah, 2 into 12 here, that is 6. 2 into 6, that is 3. And 3, that is 1. So as we can see, guys, the highest common factor must be common. So which numbers are common? 3 and 3 is common. These are the only numbers that are common. So which means our HCF, which is the highest common factor, is going to be a 3. So that was it. Okay, so if you are given to calculate these, guys, make sure of the information and how you attempt your typical questions, but that was it there. And let us just quickly, number 7, fractions, guys, in these lowest terms. So we've got 4 over 5 minus 9 over 10. So this is 4 over 5 minus 9 over 10. So as we know, guys, we need to find the LCM or the LCD of these two denominators, which is 5 and 10, that is a 10. So if we are to divide 10 divided by 5, that is 2, and 2 times 5, which is 8, 2 times 4, that is 8, minus 10 divided by 10, that is a 1, 1 times 9 here, which is 9. Then we can subtract 8 minus 9, that's minus 1, because we are subtracting a bigger number from a smaller number. So it's going to be a negative, so that's negative 1 over 10, and then we're now asked to simplify this. As you can see, this part we are actually multiplying, and here we are dividing. So this is going to be 7 over 15 multiply by 3 over 8. So remember, multiplication and division, they can be used at the same time because we have got a BOMDAS and we've got BODMAS. So it means multiplication and division can be used at the same time. You can start with division, multiplication, division. It's just one and the same thing. So what I'm going to do, I'm just going to use them at once. Convert the division, introduce to multiplication. As we know that the moment we introduce multiplication, this is going to invert. It's now 8 over 7. So it's going to be 8 over 7. So as we can see, guys, everything now is under multiplication. So which means I can reduce as long the relationship is between the numerator and the denominator. I can be able to reduce the 7 here and the 7, the 8 and the 8, the 3, 1, the 3, which is 5. So as you can see in the numerator, I'm left with 1 over 5. So it's going to be 1 over 5, just like that. So that was the condition in this case. All right, number 8, sorry, express the ratio 3,5 as to 1 in the form of A as to B, as which are A and B are integers. So we are asked to express this ratio in the form of A as to B, which is 3,5 as to 1. So the first thing, we need whole numbers. So what I'm going to do, we can just remove this comma by multiplying by 10, by multiplying by 10. So this is going to be 35 s to 1 times 10, which is 10. As you can see now, we've got whole numbers, but we can reduce this by 5, which is 7, by 5, which is 2. So this is going to be 7 s to 2. So that is it in its simplest form. This is going to give us 7 s to 2. Okay, then B, should I mix hot water? So we've got hot water and cold water. So this is hot water s to cold water in the ratio of 3,5 s to 1, which is this one that we simplified in this form. So we are going to write it as 7 s to 2. Remember, 3,5 s to 1 gave us 7 s to 2. So we are going to use this one, which is the simplified version. Now we are given that if she ended up with 45 liters of warm water, this is the total that we are given. So we are given the total of the mixture, which is 45. Okay, so that is the total of the mixture, which is 45 liters. And according to ratio, it's 7 plus 2, which is 9. So according to ratio, this is a ratio of 9. So the question now is to calculate the amount of hot water that she used. Okay, so according to the ratio, hot water is having a ratio of what? A ratio of 7. So we are saying 7 representing hot water. We do not know the amount of hot water that was used. But we know that according to the total of the ratio of 7 and 2, which gave us a 9, this 9 is corresponding to the total mixture, which is in this case is 45 liters. So we can play around simple proportion. As you can see, this is going to be less. So to find this ratio of 7 is going to be 7 over 9 times 45 liters. So that's what you're going to have. And 9 into 45, that is 5. And if you multiply 7 times 5, which is 35 liters. So which means we are going to have 35 liters of hot water in this case. So you just play around with the ratio that you're given. That's how you answer these typical questions, all right? Then for number 9, we are given that the mean of 9 numbers. Take note, these are 9 numbers that you're given. You're given the mean, and the mean of 8 numbers is 13. Find the 90th number, that is the 90th term, which was added. All right. On this type of a question, this is how you answer it. You are asking yourself that, remember, how do you find mean? Mean is equivalent to what? To the sum of terms. So these are sum of terms over number of terms, that is mean. So this is just sum of terms over number of terms. So in this case, we are saying the mean of these 9 numbers that we have got here is 11,9. So we need to know the sum of these terms. So let's say for these numbers, let's just say our sum is x. We do not know the sum. Let's just put it as what? As x. So we are going to substitute here the mean, which is 11,9, is equal to the sum of terms, that is the one that we do not know. So it's going to be x over n, which is the number of terms. And in this case, we're talking about what? 9 numbers. So these are the number of terms, which is a 9. So how can we find x, which is the sum, which is the total? The sum is the total. All right, this is the total or the sum of 9 numbers. Okay, so to find x, we can simply cross multiply. As you can see, 9 is going to multiply here, x here. So 1 times x, that is x is equal to, if we multiply properly, 11,9 times 9 is going to give us 107,1. If you multiply properly, that's the value of x, which is the sum of 9 numbers. All right, we do the same here. We ask ourselves that, what about these 8 numbers that we have got here? We know that mean, as we said, mean is what? The sum of terms. So you are given that the mean is 13. So 13 is equal to the sum of terms. This time we are referring to the sum of these 8 terms. So in this case, let y be the sum of terms, which is for these 8 terms. I'm just going to use y to represent what? The sum of the 8 terms. All right, so I'm going to put y here over the number of terms. Take note over n. How many terms? We are talking of 8 terms. So it's over 8. So to find the value of y, which is the total, we are just going to cross multiply as what we did previously. So 1 times y there, that's y is equal to 13 times 8, which is going to give us 104. All right, so how now are we going to find our answer? We are saying this is the total here. This is the total of 9 numbers. This is the total of 8 numbers. So how can we find the 9th term, the number that was added? Because previously the 8 numbers gave you 104. So you can just formulate an equation to say 104. This is the sum of 8 numbers plus the 9th term, which was added. We added another term here, which is the 9th term, and we do not know that term. We can just say that term is A. We got a total of, because this is a sum of 8 terms plus the 9th term. This is the 9th term. We must obtain this sum of what? Of 9 terms. Take note, we are talking of total of 9 terms. So we must obtain 107,1. So that's what you're going to have in this case. So what is going to be the value of A, which is the 9th term that was added, this one. So A is going to be 107,1 minus 104. So if we subtract properly here, we are going to obtain 3,1. So that means our A, that is the term, which is the 9th term, the one that was added, was going to be 3,1. So it's all about finding the sum of the 9 terms, the sum of the 8 terms, then you can just subtract to say sum of 9 terms minus sum of what? Of 8 terms, so that I can find what? The 9th term, which was added. So that was the condition of the question, guys. As you can see, so it was actually 3 marks for everything. All right, solve the equation. This one is a quadratic equation, so you can choose factorization. Definitely, we're in paper 1, so let us try to work with our factorization so that it can help us here. So remember, factorization, multiply the first term and the last term, and we are going to have negative 6x squared. That's negative 6x squared. What are the factors of negative 6? So you need factors of negative 6 that we are going to add to obtain the middle term, which is negative 5. So we are having negative 6 at 1. If we multiply these two, we get negative 6. If we add, we get negative 5. So we're going to have replace this in the middle term. That is 3x squared. In the middle term, we are going to replace negative 6x plus 1x, and 1x is just same as x. All right, the last term you just repeat as it is, you just rewrite as it is. All right, so as you can see now, we have got 4 terms, and we can perform our factorization because we can group our terms into 2 like that. So what is the first common term here? We've got 3 and 6. 3 is common, x squared, and x is common here, so you can factor 3x. So 3x squared divided by 3x, that's x here, minus 6x divided by 3x, which is negative 2. So as you can see, guys, this bracket is actually the same as this part that is remaining. So what are you going to factor out so that the brackets will be the same? Definitely, that's a plus 1. So that's what you're going to have. It fetched everything to 0 there. This bracket and this bracket are now the same. So you just factor out the common bracket, and we are remaining with 3x plus 1. So that's 3x plus 1 into another bracket and equate these two to 0. So that means either one of these brackets must be equal to 0. That's either this or this must be equal to 0. So that means we are going to have either x minus 2 being equal to 0 here, or 3x plus 1 being equal to 0. So x is going to give us what? A 2, or in this case, x is going to be this to the other side of the equation. 1 is going to be negative 1. So it's going to be 3x is equal to negative 1. Divide by 3, definitely both sides. So our x is going to be negative 1 over 3. All right, so that is the case. So you're going to obtain 2 possible values of x. That was it. Yes, you can use quadratic formula and so forth, but it was just factorization was the best. All right, find the square of 1 over 4, guys. The square simply means to the power of 2. That is the square. Not square root, but square like this. This is the square. So 1 squared, that's a 1. 4 squared, that is a 16. So it's going to be 1 over 16. All right, calculate the rate at which 500 is going to earn $320 simple interest in 4 years. So you need the rate whereby we know that interest is equal to PRT. So that is principal times rate times time over 100. So that is it. Our interest, we can actually substitute. Remember, this man is going to earn 320 simple interest. We are given the simple interest of 320, whereby we invested $500. So $500 was invested. Sorry, this is $500 which was invested times the rate. This is the one that you want to calculate, times the time. The time is already in years, so you just use it as that. Everything over 100. So the moment we do this, we are going to have our R here as a percentage because we've reused the 100 here. So that's it, guys. How can you find this? Or you can just, before you cross multiply, you can even reduce these two. It's going to be easier that way. I don't know which was the best way for you, but you can actually reduce 500 and 100 here. These 2 zeros here, these 2 zeros here. All right, so 5 times 4, that is 20. So it's going to be 320 like this is equal to, we said 5 times 4, that's 20R. So it's going to be 20R. So to remove this 20, just divide by 8 both sides, divide by 8 both sides. So we can actually cancel these two. So therefore, our R in this case is going to be, if we reduce this, that's 2 into 32, which is 16. And remember, R is a rate, which is a percentage rate. So it's going to be 16%. That is what you're going to have in this case. That was it, guys, as you can see. All right, given on number 12, we are given, in this case, the universal set. And the universal set, as you can see, guys, it's of elements which is from 10 and they are less than these elements. They are starting X is greater than or equal. Take note, there is this equal to like this. It means we are going to start from 10 up to 19 because we are given that X is an integer, but it's less than 20. It's not equal to 20, it's less than, there is no equal to here. So we're going to start from 10, 11, 12, that's right. So let's try to be slow as it needs. So this is going to be 12 here. All right, we move on, that is 13, 14, we've got 15, we've got 16, we've got 17, 18, we've got 19. So we're going to end up to 19 because 20 is not included in this set. Okay, so this is our universal set. So that is your universal set in this case, okay, which is equal to this part. And we are given set A, which is of elements of prime numbers. So we are talking of prime numbers from 10 up to 19 from this universal set. That is where your A is going to be taken from. So which means our A, which are the prime numbers, guys? As you know, prime numbers, these are numbers that are divisible by 1 in itself. So we've got 11, 13. These are the prime numbers. Which other prime number? We've got 17. 17 and 19. So it's going to be 17 and 19. So these are the prime numbers that we are going to actually have in this case. All right, so it was just a matter of listing the prime numbers for A. Then we move on to B. B is said that X is a factor of 3. So as you can see, guys, we do not have any factor of 3. These 12, 15, 18, these are multiples of 3. So here we do not have any factor of 3. It does not exist. We do not have anything here. Take note, guys, we are talking about our universal set from 10 to 19. So between 10 and 19, we do not have a factor of 3. We've got multiples of 3. So there's nothing in this set. Then B is a set. So it's actually B is an empty set, this one. So you just put it as an empty set. All right. Then C is a set of X, so that X is an odd number. So we are talking of odd numbers here. And which odd numbers that when you divide by 2, there is going to be a remainder of 1. So you're talking of 11, 13, 15. Then we move on to 17 here. And 19. So you see that some of the prime numbers, they are also odd numbers. All right, it's fine like that. Okay, so the first question on number A was to write down the largest element in subset A. What is the largest element in subset A? So as you can see, this is our subset A here, and the largest element or the largest number that you can see in set A is 19. Okay, so that was a 19. Okay, B, find number of elements in set B. Do we have anything in set B? This is set B, there's nothing, it's an empty set. So this one is going to be a 0 here. All right, then list the elements of A intersection C. So we have to list what do we have between A and C on the intersection. So we've got C and A here. 11 is common. Okay. We have got 13. 13 is common. All right. Which other part? We have got 17. 17 here is common. All right. We have got 19. 19 here is common. All right, so that was it. As you can see, that's in the intersection of A and C. What is common for these two sets? That is what? That is the intersection, what is found in between the two sets. That was it. All right, on number 12. On number 13, it is given that there is a line L of a side of a square that is 7 centimeters. So this is a square. Remember that a square, guys, all sides are equal. So it is 7 here, it is 7 here, it is 7 here, it is 7 here. Okay, but these measurements were done to the nearest centimeter. All right, so the question is for us to write down the range, okay, where the length is going to lie in between this L. So as you can see, guys, we know that the minimum value is supposed to be 1 digit less than this, which is 6,52. The maximum value is supposed to be 7,4. All right, but let's take a look of how this inequality is given. They are given that L is greater than or equal to. So the equal part means the least value is going to be involved as it is, which is 6,5. But here we are given that our L is less than, be not equal to. So which means this one is directly equal to this, but this one, if we say less than this, is going to be wrong. So it must be less than 7,5. So that is now in the region. The value that we need is 7,4. So which value is, how can we write this 7,4 in terms of less than? So we are going to write as less than 7,5. The moment we write 7,5 like this, it means 7,5 is not involved. You need values which are less than 7,5. That means we are talking of now 7,4, 7,3, 7,2, and so on. So that's what how you write. But if it was given like this, L is greater than or equal to B, less than or equal to B like this. All right, greater than or equal to A, but less than or equal to B. Then you're going to write this as 7,4 and this one as 6,5. The 7,4 was going to be written now. All right, so make sure you understand the inequalities there. All right, then B, calculate the least possible perimeter of the square. So as we know, guys, perimeter of a square is equal to 4s, 4 times one side, or you add the side plus side plus side plus side, but we need the least. So for you to find the least possible perimeter, you must use the least value here, which is 6,5. So this is the one that you're going to use. So it's 4 times 6,5, which is going to give us what? 4 times 5, that is 20 here. 4 times 6, which is 24, plus 2, which is 26. And we've got one decimal place, which is 26,0 here. And 26,0 is same as what? Is same as 26 centimeters. So this is perimeter. So it's just going to be centimeters, just like that. All right. So you're just going to write it as 20 centimeters, 26. If it was the largest or the maximum, you were going to use this value 7,4, not 7,5. We use this one that we have on the limit. This is your minimum. This is your maximum. So when calculating, you use this. All right. Let's say they wanted you to find the maximum possible perimeter. That is what you're going to do. All right, on number 14, we are given a trapezium, in which is PQRS and the angles and so forth. So the first question was to calculate the area of the trapezium. Okay, guys, this is another type of a question. Oh, actually, we know that the area of a trapezium is supposed to be like this. Half sum of the parallel sides times the perpendicular height, whereby in this case, this is our perpendicular height. Guys, where I'm drawing this line now, let me just try to shift the way I am having this line. So we are going to have from this point direct to this, that's our perpendicular height, or it can be here. From this angle here. All right, so we can actually have our perpendicular height, which is this one, which is our perpendicular height, which is our edge. All right, so that's what we have got, and it's going to be at 90 degrees. As we know, guys, this height is going to be at 90 degrees. Okay, so if we are to cross check here, the A and the B, the sides that are parallel, they are there. We have got 5, which is parallel, and this 11, but we do not have this perpendicular height. All right, so that's now where we are going to use as much of this information that is given below now to find this height. Why? Because if we are to cross check, guys, if we are to divide this triangle like the way that we did here, we are going to have a right angle triangle here. And we know that from this point here, this is what we have got. We want to find this point from P to this point. All right. So using this right angle triangle, I want us to see something. We are given an angle of 30 degrees. And according to this angle of 30, this is your opposite here. And this is your hypotenuse. So which ratio are you going to use? That has got opposite and adjacent from your soccer tower. So remember your soccer tower there. All right, so that's what you're going to have. So which one has got opposite and hypotenuse? That's sine, opposite, hypotenuse. So you can apply our sine rule to calculate this height, because we know that sine theta is equal to opposite over hypotenuse. So this is opposite over hypotenuse. All right, so sine theta, which is sine of the angle that we are given here, which is 30 degrees, is equal to the opposite, which is this height that we want to calculate. That's our opposite, which is h, over the hypotenuse, which is the side that you're given of 8. So how can we find h? We can just cross multiply here, 1 times h. That is, h is equal to 8 times sine 30, which is 8 sine 30 degrees. All right, so that's it, guys. So this is paper 1. You do not have calculators, so but we have got advantage because we are given that sine 30 here, it's 0,5000. Okay, so take note, guys, these zeros after the comma, they are not important. It's just the way of writing, because all these values, they are given as 3 digits after the comma. But when writing, you just use 0,5. All right, so here you are going to multiply with 0,5. So our h is going to be 8 times 0,5, of which you know that 0,5 is just multiplying by half. This is going to give us 4. Or you multiply 8 times 5, which is 40 here. Our main decimal place, we have got 1. So it's going to be 4,0, which is 4. All right, so we've got the height, which is 4 centimeters here. That is our height, guys, which is 4, which is the same here as 4. So that means we can now find the area, because this was the only part that was missing on our question. Now the area can be determined, because we know that the area of a trapezium is given by the formula of sum of the parallel sides. And which sides are parallel? Said in this case, we've got 5 here, and this 11 from this side to this side. So we're going to add 5 plus 11. That is A plus B. So that's 5 plus 11 here. So we're going to have 5 plus 11 times the perpendicular height, which is our height, the one that we just determined now, which is 4. So that is our perpendicular height. So we're going to multiply by 4 in this case. So that's it. We can have our area. So if we add these two, that's going to be 16, 5 plus 11, that is 16 here. And we can divide by 2. 2 into 16, that is 8. And if you multiply 8 times 4, which is something like 32 square centimeters. All right. So this is our area, guys. That's what we just needed, which is 32. So as you can see, guys, it's a matter of playing around with the questions. You must understand your questions, play around them. And it's very, very easy if you understand the concept. And on number 15, we are given 15a. What is the number of lines of symmetry of a general parallelogram? So a parallelogram does not have any line of symmetry when it is a general parallelogram. So this one is a 0 here. All right. Then on B, find the exact value of 4mn, giving your answer as a decimal. Okay, so we have to multiply 4 times m. This is our m, which is 4 times 10 to the power of 4 times n. Our n is 5 times 10 to the power of minus 9. So what are we going to do? We are just going to multiply the numbers together. That is 4 times 4 times 5. So if you multiply 4 times 5 here is actually 20. 20 times 4, which is 80. So this is 80 here. Then on these two, we are going to apply the laws of exponents. Since we are multiplying the bases which are the same, so we are going to add the exponents, which is 4 plus minus 9, like this. All right. And plus and minus, we know that this is going to give us a negative here. So it's now 4 minus 9, which is minus 5. So it will be 10 to the power of minus 5. So that is times 10 to the exponent of negative 5, like that. So that's what you're going to have. But we are given to write this as a decimal. So how are you going to remove to the exponent of what? Negative 10. So remember, guys, that if you to remove this, you have to move 5 commas to the left because you've got a negative exponent. So from this number here, at that point, that is where our comma is. Where your comma is after this. So let us move our commas to the left. That's 1 here, 2 here, 3 here, 4, and a 5. So your comma is now at this point. This is where your comma is. So which means you are going to put zeros here inside. That's a 0 here, there, a 0 here, and a 0 here, because it's supposed to be 0 comma. This is where your comma is at this point here. So make sure that you put this 0 here. So it's going to be 0 comma. You write this 0 0, which is 0 0 0 8 0. This one is no longer important because it's after the comma. So you just write it as 0 comma 0 0 08, just like that. That was it, guys, as a decimal. So answer the question. The question is saying as a decimal, not in standard form, but as a decimal. All right, so that was it. Then 16, we are given the matrix T. The given matrix T, determine the determinant. So guys, as we know, that determinant is simply the product of major diagonal minus the minor. This is your A, this is your B, this is your C, this is your D. So you know, the determinant of T is going to be AD minus BC. All right, so you're going to multiply A times D here, which is 3 times 1. So that's what you're going to have, minus BC, which is minus 6 times 4. So it's minus 6 times 4. So that's what you're going to have. Apply 3 times 1, that is 3. Minus here, minus and minus is going to be a plus. So this will be a plus 6 times 4, which is actually 24. So if we add this, we are going to obtain 27. Just like that. The question is asking you to determine determinant just like that, determinant just like that, guys. Okay, then B, if n is, this one is now a vector, find the modulus of n in said form. So remember, guys, the determinant, the modulus, guys, this is now vector. So this question is it's not good what they do, that you mix vector and matrices. Okay, the determinant is for matrix, then this modulus is actually for vectors whenever you're given in said form. That is for vectors. Okay, so we need the modulus, where I told you guys the modulus of a number is given by the formula of what? X squared plus y squared. That is the formula for the modulus, where this is your x here, this is your y. So which means the modulus of n is going to be the square root of our x, that is minus 3. So it's going to be negative 3 squared plus the value of y here, which is 9 squared, just like that. So you can simplify further. Minus 3 squared, that is 9. That's negative 3 times negative 3, which is 9, plus 9 squared here, which is going to give us 81. So if we add, we are going to obtain a 90 here, if I'm not mistaken. That's a 90. All right, so that's it. But we can actually write in simplest form. Remember, the perfect square that we have got in 90, it's 9. The highest perfect square in 90 is 9 times 10, whereby square root of 9 is 3. Square root of 10, we can't simplify this. So which means in simplest form is going to be 3 square root of 10. Or you can express 90 as a product of its prime factors. I think I explained all those methods of, okay, let us just have it here. 90 as a product of its prime factors, 2 into 90, that is 45. 3 into 90 here, into 45, that is 15. 3 into 15, that is 5. 5 into 5, that is 1. So remember, guys, I told you that a number that has got a pair, you write it outside of the square root. Here you've got a 3. You write it outside of the square root. Then these numbers, they do not have a pair. You write them inside of the square root. So you're going to have 2 times 5 under the square root. So it's going to be 3 square root of 10 in its simplest form. So that's it, guys. But paper one, mostly they can actually mark this one at this stage, but just try to write in what? In simplest form. So this is the simplest form that you can have in this case. All right, so that was it, guys, for this particular question. Yeah, as you can see, guys, it was just somewhat like that. You just have to revise as much as you can. Number 17, given that d is equal to 2n minus 1, find d when n is equal to 1. So it's just a matter of substituting here, guys. As you can see, in place of n, we are going to substitute 8. So it's going to be 2 times 8 minus 1. All right, that's 2 times 8, which is 16, minus 1, which is going to give us a 15. All right, so this is going to give us a 15, just like that. On a scale that is on map there, on a map of a scale 1s to 50,000, there is 1s to 50,000, a stream is 7 centimeters long. Calculate the actual length of the stream, giving your answer in kilometers. Okay, so remember, guys, I told you that the scale, as you see it like this, it represents 1 centimeter on the map as to the 50,000 centimeters that is on the ground. So this is 50,000 centimeters on the ground. So you can play around these 50 centimeters to convert it to kilometers first, so that we can know that what does this 50,000 centimeters represent actually in kilometers. So how are we going to do this? We can do this stage by stage. If you know that division to convert kilometers to, centimeters to kilometers is difficult for you, then do it stage by stage. What do I mean? You can convert this 50,000 centimeters to meters, which means you're just dividing by what? By 100. So 50,000 divide by 100, it means now it's in meters, which is 500. So this is same as 500 meters. Then you can move on 1 centimeter as to, how do you convert meters to kilometers? You divide by 1,000. So it's 500 over 1,000, and that's 0, 0, which is 0.5. So this is going to be 0.5 kilometers like this. Okay, so it means on the map, 1 centimeter is equivalent to 0.5 kilometers on the ground. This is on the map, and this is on the actual ground. That's what you're going to have in this case. Okay, so if we have got a stream that is 7, the 7 centimeters is on the map, all right, because we want to calculate the actual length. The actual length is the one that is on the ground, that is the actual part. Okay, so you are given 7 centimeters, so you're going to equate now to say what is going to be represented by 7 centimeters on the ground. What does this 7 centimeters going to represent? So as you can see, guys, it's just a simple proportion, which is going to be a more here. That's 7 over 1 times 0.5. All right, so let's multiply, guys. 7 times 5. That is 35. How many decimal places do we have? We just have 1 decimal place, so it's going to be 3.5 in kilometers. Take note, this 0.5 is in kilometers. These were centimeters, so these two will cancel, and your answer is going to remain in kilometers like that. All right, so that was the question, guys. As you can see, it was just a light question. Yeah, very light. Just so all you need is to work on it as much as you can. Write down the 3-figure bearing equivalent to the northwest. What is the 3-figure bearing that is equivalent to northwest? Northwest is like this, guys. This is your north here. All right, let's just have our north pole. So this is our north, and this is our west. So northwest, it means it's in between the north and what? The west. In between. That is in between. So it's going to divide this into 2 equal parts, which means here we have got 45 degrees, and here we've got 45 degrees. So definitely the 3-figure bearing, because here what we need, guys, this is the compass bearing that we are given of north west, but the question needs us to find the 3-figure bearing to represent this, and we know that 3-figure bearing is taken from the north in a clockwise direction. So this is what you're going to have as your 3-figure bearing, which is at 270 degrees. The whole of this angle here is 270 degrees. This angle from this point to this point is 270, 90, 90, 90. That's 270. So we are going to have 270 degrees plus this 45 here. So we are going to add 45 degrees, and that's 5, 11, 1 here, which is 315 degrees. Okay, so we are going to have 315 degrees as the three figure bearing, which represents what? Northwest. That is it, guys, just like that. All right, so that's how you answer these questions, just like that. All right, so there we are given the diagram shows a regular polygon. Take note, this is a regular polygon with the angles marked X and so forth. What is the value of X and what is the value of Y? All right, so let's see, guys. This is a regular polygon. How many sides do we have? We've got 1, 2, 3, 4, 5, 6. So this one has got 6 sides, which means that's a regular hexagon. And guys, the X here represents the exterior angle. As we can see, that's an exterior angle. This X, exterior angle, exterior angle, exterior angle. All right. And we know that all the exterior angles, they add up to 360 degrees. So we're just going to divide 360 degrees, divide by how many exterior angles? This is a hexagon where we said it's got 6. So we're going to divide by 6. That's 6 into 36, which is 6. 6 into 0, that is 0 there. So we're going to have 60 degrees. So this is going to be 60 degrees here, another 60 degrees, another 60 degrees, each and every angle, because it's a regular polygon, so they are actually equal throughout. All right, so that was it, guys. Throughout, our X is going to be 60 degrees. And what about the value of Y? Y is an interior angle, as you can see, and these two, they are on a straight line. So we are just going to subtract 100, this 60 from 120 degrees, from 180, sorry, so that is going to be 120. So our Y is going to be 180 minus 60 degrees, and that's 120 degrees, which is the value of Y. All right, so that was the value of Y in this case, which is 120 degrees. So do you see, guys, knowing your polygon in calculations and also knowing your polygons in presentation like this must be known, because they can take that as an advantage to ask you this particular question while you are used to normal calculations. So you must be able to relate from the diagram to your calculations. That's how you answer these questions. All right, anyways, solve the inequality on number 19A. That is as we know, guys, these are simultaneous inequalities where you are given two inequalities like this. So remember, I told you, you divide your inequality into two, separated by the middle term in between these two inequalities, and the middle term here is 28. So that means we are going to have this first inequality as 3x plus 1 is less than 28. So that's what you're going to have as your first inequality. The second inequality starts from 28. So it's going to be 28 is less than or equal to 5x minus 2. So that's it, guys. Let us solve our inequality. We can transpose here to the left to the right-hand side. There's going to be a negative, so which means we are going to be left with 3x is equivalent to 28 minus 1 here, which is actually 27, and we can divide by 3. So guys, this is less than ym. All right, something like this, less than. So you can divide by 3 here. So that means our x is going to be less than 3 into 27. That is a 9. Okay, we are done on this stage. We move on to this. We do the same, transpose this negative 2 to the other side of the inequality is going to be a plus 2. So it's 30 here from 28 plus 2. It's going to give us 30 is less than or equal to. You maintain the inequality sign as it is, so you can divide by 5. So that's it, guys. So our x is going to be greater or equal to 5 into 30. That is a 6. So now we are supposed to combine our inequalities, guys. We are supposed to combine these inequalities that we are given. That means the first part here is going to give us x, which is less than 9, and the one which is x is greater than or equal to 6. So how are you going to combine? Always start with the smallest digit, which is this one. So according to this x, we are saying this x is actually greater than or equal to 6. And the same x that you're talking about is less than 9. So this x is also less than 9. So that's it, guys. You combine your inequality to give you one solution. All right, so that was it. We have got the number line that we are given on B that we are supposed to indicate now here on B. Show the solution in A on a number line. So we want to take this part, guys, on our number line and see what you're going to have at the end. So let's just see, guys, if we are going to win in this case. All right, so you just want to take this part. Why is it now indicating everything? I just want this part. Now it takes everything. All right, anyways, let us just have it like that, guys. It's going to give us trouble now. Let us just take it as it is. All right, so this is x is greater than or equal to 6. It was like this, x is greater than or equal to 6 and less than 9. This is what we're given. Okay, so which means we are going direct at 6 here and at 9. This is our 9 here. All right, so you know that at 6, x is greater than or equal to 6, which means we are going to shed is included. The 6 is part of our solution. All right, then these two, you just join them like that. It's in between, just like that, guys. You are done. All right. Then from this, the question now goes further to, if x is an odd integer, remember an odd number, when you divide by 2, it gives you a remainder of 1. Then write down the least value which satisfies this inequality. So we need to know the values which are part of this solution from 6 here up to 9. So which means we are talking of 6, 7 is included. We are talking of 8 is included, but 9 is not involved because we didn't shed this part. So 9 is not included. So from these numbers, which is the least odd number that we have, and we only have one odd number here, which is 7. So that was going to be our x, which is the odd number, because x here is representing the least odd integer. All right, so that was it, guys. An integer, that is a whole number, positive or negative. Number 20, we are given to convert 101 base 2 to a number in base 6. Okay, this is 1001 in base 2 to base 6. All right. So as we know, guys, we can actually do shorter ways. There are so many shorter ways that you can do, or you can just do the longer way, converting this to base 10, where I told you that you just need to raise to the exponent of the base, which is your base, which is 2. So this is 2 to the exponent of 0. Okay, sorry for that. Sorry, guys. Let me adjust. Okay, 2 to the exponent of 0 here. 2 to the exponent of 1, 2 to the exponent of 2, 2 to the exponent of 3. All right, so that means we are going to multiply these now. 1 times 2, so it's going to be 1 times 2 to the exponent of 3, plus here, we are not going to waste much time. This is 0 here, multiply here by 0, there's nothing, that's a 0 here. Then we move on to this 1 here, which is 1 times 2 to the exponent of 0, like that. All right, so 2 to the exponent of 3, that's 2 times 2 times 2, 3 times, which is going to give us 8. 2 times 2, that's 4. 4 times 2, which is 8. Then 8 times 1, that is 8. 2 to the exponent of 0, that's a 1. 1 times 1, which is 1. So if we add this, is going to give us a 9, which is in base 10. All right, so this 9 is in base 10, then we can convert to base 6. How do you convert to base 6? You just divide by the base throughout, noting the remainder. So dividing by 6, noting the remainder here. So it's 6 into 9. That's 1, remainder 3. Then we divide here 6 into 1 here, that's 0, remainder 1. Then your answer taken from the bottom going upwards, so it's going to be 13 in base of 6. All right, so that was it, guys. 103. 13 base 6, not 103. So guys, 13 in base of 1, in base of 6, just like that. Okay, B part, we are given that 111 base n is equal to 73 base 10. And actually, I did this type of a question in our previous question paper, if you still remember, guys, where I told you that when you're given this type of a, just convert this to base 10, because this is easier for us to work in what? In base 10. So convert that number to base 10. Just like what we did here, raising in exponents, that's n to the exponent of 0 here, n to the exponent of 1, n to the exponent of 2, just like what we did previously. So that means we are going to have something of this nature. We are going to have something of this nature here, 1 times n to the exponent of 2, plus 1 times n to the exponent of 1 here, 1 times n to the exponent of 1 plus here, that's 1 times n to the exponent of what? To the power of 0 here, just like this. And you equate now to 73, which is in base 10. So we remember, by doing this part here, you are converting to base 10. So whatever that you're going to get is in base 10. So which means you can equate now to 73 in base 10 without any base. Remember, you can write 73 in base 10 without writing the base, just like what I did here. 9 can be written as 9 base 10, or you can just write it as 9 the way that I wrote there. All right, so now this is our normal equation, guys. Forget about number bases. This is now you and your normal equations. How are you going to solve this equation? All right, n squared, that is n squared times 1 is just going to be n squared. N times 1 is just going to be n. N to the power of 0, that's 1. 1 times 1, that's a 1, which is equal to 73. So as you can see, we have formulated a quadratic equation. So you have to transpose this 73 to the left-hand side of the equation. That's n squared plus n. So it's going to be n squared plus n. So this is plus n. 1 minus 73, that is minus 72. So it's going to give us a negative 72 in this case. So as you can see, guys, we are supposed to factorize because here the coefficient of n squared is 1. So I just have 2 brackets that I'm going to have, which is 2 brackets here. All right, equate them to 0 here. I'm going to put n. So it's an advantage whenever the coefficient of this is 1. Remember, I told you this. Okay, so we're going to focus now on these two, minus 72 and this coefficient of n, which is 1. Okay, so what are the factors of minus 72 that we're going to add? And they will give us a positive 1. So this is 9 and minus 8. All right. If I multiply these two numbers, I get minus 72. If I add these two, I get a positive 1. It must be a positive 1. So I've got 9 and minus 8. So this is going to be plus 9 here, minus 8. So that's what I'm going to have. All right, so equating this to 0, that means n plus 9 is equal to a 0 here, or n minus 8, sorry, is going to be equal to a 0. That's it. So taking this part, we can actually remove. Okay, so we're going to just equate this minus 9 to the right-hand side. That's going to be a negative. Plus 9 becomes a negative. Negative 8 becomes a positive. So n is going to be positive 8. So because of the n representing the base, remember your n here is representing a base, and a base can only be positive. We cannot have it as a negative. So therefore our n here is going to be this one, which is a positive, because it can't be a negative value. So therefore our n was going to be 8. All right, so that was it, guys. As you can see, it's a matter of application. The application part is supposed to be done here properly. Okay, number 21, we're given the circle, that is your circle geometry, and we are given, that is the circumference of the circle, center, or that is only the information that you are given. So as you can see, guys, this is the center, which means from O to B, that's a radius, from O to A, that's a radius, and these two angles, we know that they are equal. Base angles of an isosceles triangle. So this one is going to be 30 degrees also. So the first question is to calculate A or B. That is the first question, A or B. That is A or to B, this angle here. So definitely taking this advantage, we know that angles in a triangle, they add up to 180 degrees. So we can take that as an advantage, subtract the two angles from 180 degrees. We can have our A or B. That's 180 degrees minus the two angles, which is 30 degrees plus 30 degrees. All right, so that's it, guys, which is going to be 30 plus 30 here, that's 60. So 180 minus 60, which is going to give us 120 degrees, just like that. All right. So as you can see, guys, it was actually direct. Okay, what about ACB? ACB, this is your ACB here. This is our ACB, the one that we want to calculate. All right, take note, we just calculated this angle here, and we said it's actually 120 degrees here. We say this angle is 120 degrees. All right, and there is a relationship between this angle at C not with this angle, but with this reflex angle here. What is the relationship? We know that angle at the center is twice angle at the circumference. So, which means the angle at the circumference is half of this one at the center. So take note, guys, 120 does not affect this angle. 120 was going to affect the angle that was going to be created here. If it was like this 120 was going to affect this angle here, but it's not like that in this case. So 120 is not going to work for us to find this angle, but it is going to help us just to find this angle that is the reflex AOB. So we're going to find reflex AOB. All right, the reflex AOB is going to be this angle that is remaining, which is 360 degrees minus 120 degrees. And that is going to be 0 here for 2. So it's going to be 240 degrees. That's what you're going to have. And now we say this reflex is twice the angle at C. So which means a CB is going to be half of this because it's on the circumference. All right, so our ACB is going to be half of the 240 degrees that we obtained from the reflex from the reflex AOB, this one, which is 240. So half of 240, that is 120 degrees. All right. So that was our reflex, that was our ACB, yeah, from the reflex angle. So guys, know your theorems. You see how they can ask these questions. It's very, very, very important that you know how they ask and so forth. All right, number 22, a given matrix R is given by 3001, and it represents a certain transformation which maps P onto P1. Take note, guys, we are given the image, which is P1. And the question is to calculate the value of X and the value of Y. Okay, the value of X and the value of Y, they are here on the object. This is your object, all right. And this is your image. Guys, remember I told you that the matrix, yes, it's true that our matrix times the object is going to give us the image like this. But this time you are not calculating the image. You want to calculate this object. You are already given the image. You want to calculate the object because P is your object here, where there's X and Y. This is your object. So how are you going to calculate the object? For you to remove this matrix here, which is M representing the matrix, you are going to write it on this side. To write this matrix on the other side of the equation here, you write it as an inverse. So it is going to be the inverse of the matrix times the image of the line or the image of what? Of the shape or the point that you are given. So this is the inverse of the matrix. So it's going to be inverse matrix like that. All right, so that is the condition, guys, that you do. If you want to calculate the object, you multiply the image with the inverse of the matrix. But if you want to calculate the inverse, this image like the one that we are used to, we just take your matrix direct as it is. Your matrix, you multiply it to the object direct as it is. But now, because you are given the image, you are going to do a vice versa now, which means you multiply by the inverse. So take note about this relationship, guys. Okay, so object is equal to inverse matrix times image. All right, so that means we have to find the inverse because here we are given the matrix. This is your matrix here. So you need the inverse of this matrix because already the image is there. This is your P1. So let us first find the image of this, the inverse of this matrix R. So as you know, guys, to find the inverse, we must first find the determinant of that matrix, which we said is AD minus BC. So as you can see, guys, we calculated this before. 3 times what? 3 times 1 here, minus 0 times 0, that's a 0 here, 0 times 0, which is a 0. 3 times 1, which is 3, minus 0, which is going to give us a 3. Okay, so that's your determinant, and the inverse of the matrix now R is equal to, remember inverse, it's 1 over the determinant, which is 1 over 3. All right, what happens with the major diagonal? The A and the D, remember they interchange their position. So it's going to be 1, 3, and this you multiply by negative, but 0 does not get affected by a negative. It's just going to remain like that. All right, so we now have the inverse of the matrix is now there. All right, so let us apply this formula here. We said the object in this case, that is our object, which is in this case, our object is the point P. All right, so P, which is the one that we want to calculate, is equal to the inverse of the matrix, which is this one. This is the inverse of the matrix that we calculated here, 1, 3. So it is going to be 1, 3, that's 1, 0, 0, 3. All right, so you take this matrix of the inverse as it is not R, but its inverse, okay, times the image. This I here is for the image, okay, and our image in this case is P1, which is 3, 4. That's our image, which is 3, 4, which is point P1. So you write it as 3, 4, like that. All right, so that's it. You can perform your matrix multiplication row by column. So it's going to be row by column here. So that means this part is going to remain as it is. That is 1 over 3. 1 times 3 here, that is a 3 plus 0 times 4, that's a 0 here. Okay, we are done with this row and the column. Then we move on to this row and this column again. All right, so which means this part is going to give us 0 times 3, that's a 0 here, plus 3 times 4, and 3 times 4, that's 12 there, as you can see. All right, so you can add, that's 1 over 3 into 3 plus 0, which is a 3, 0 plus 12 here, which is a 12, and you can multiply 1 over 3, okay, let's just write it here, 1 over 3 times 3, that's a 1. 1 over 3 times 12, which is a 4, like that. All right, so this is our point P that we are going to have as coordinates like this. Our point P as coordinate, which is 1, 4, like this. Just like what we did on this image, it was 3, 4. But when we were multiplying, we wrote it as a column like this, 3, 4 as a column. So it's the same thing. Our answer, we obtained it as a column, so we're going to write it as a point now like this. But let us answer the question. The question needs us to find the value of x and the value of y. So here from point P, this is your x, this is your y. So now, which means from this point P, this is our x, this is our y. So which means our x is going to be 1, our y is going to be 4. So that's what you're going to have. So please answer the question. Do not just write, answer what the question is asking you to do. All right, that was it, guys. As you can see, it's just a matter of application of the information given that the point B here. All right, let's just do this. This is our point B. We are given the value of R, the value of S and T. Then the first question is asking us to find R to the power of S, or to the exponent of S. So it's just a matter of substituting your R. In this case is 27. So that's 27 to the power of S, which is to the exponent of S, which is 1 over 3. So it's to the power of 1 over 3. So once you are at this stage, it's now back to you and your laws of exponents, your laws of indices, where we know that this means what? The cube root of 27, because we are given 1 over 3 as a fraction. So it's the cube root of 27, everything to the power of 1. So what is the cube root of 27? It's 3. 3 to the power of 1, that's 3. All right, so that is it, guys. Item 2. That's s to the power of minus t, or s to the exponent of minus t. All right, so s here is our s, which is 1 over 3. All right, so our s in this case is 1 over 3. Everything to the power of minus t. Our t is a 2, so it's going to be to the power of minus 2, like this. All right, so let us apply our laws of exponents. How are we going to remove this negative here? So remember, guys, I told you to remove a negative, you invert this fraction inside. So if we invert this fraction, it's going to be 3 over 1. So we have removed the negative 2 here by interchanging this fraction here. So it's 3 over 1, which is same as 3. 3 over 1 is just same as 3 to the exponent of 2, which is going to give us a 9. So that was it, guys, from this question. The value there is going to give us a 9. So this is to the exponent of minus t. Is it minus t? Or yeah, that is minus t, guys. This one is to the exponent of minus t, not minus 1, but to the exponent of what? Minus t. So that was it, guys. You get a 9. in that case. All right. Let's see, 23, we are given to factorize completely. Guys, as you can see, this is a perfect square 4. It's a perfect square from 2 squared. Okay, already this is x squared minus y squared. So perfect square, perfect square, perfect square. So we're going to have this as difference of 2 squares. That's 2x. One bracket is going to add, and another bracket is going to subtract. That's 2x minus y, just like that. Okay, so we're done here. Given that 2x plus y is equal to 10, solve this equation, solve the equation. Okay, so guys, I want us to see something. We are given this value of 2x plus y, which is 10 here. All right. Yes, we can solve this equation, but are you saying that this is a quadratic and it's going to take us long if we are to work with this quadratic? So how can we avoid working with this quadratic? Okay, I want you to take this stage here that we are given on this part. We are given that 4x squared minus y squared is equal to what? Is equal to 40 here. That's what you're given. But previously, we were given this 4x squared minus y squared, and we said it's going to give us these two brackets. When we factorize it, it's going to give us 2x plus y like this into 2x minus y like this, which is going to be equal to 40. So actually, this part, 2x plus y and 2x minus y is what? Is the 4x squared minus y that we had before. But now we know that in place of 2x plus y, we are going to put what? 10, because we are given that 2x plus y is 10. So in place of this 2x plus y, the whole of this part here is going to be replaced with 10. So you're going to be left with 10 into 2x minus y like this, then you equate to a 40. So it's like you have used the numerical value. So what is going to represent this bracket of 2x minus y? So you can divide by 10. Yeah, simply divide by 10, guys. As you can see, it's easier that way. You can simply divide by 10, both sides by 10, both sides by 10, both sides like that. So 10 and 10 can cancel, which means you are going to be left with 2x minus y, which is equal to this, and this can cancel, which is a 4. Why am I writing this? It is going to be easier for us now because we are dealing with what? With linear equations now. This is a linear equation that you're going to take. In place of this, you are no longer writing this, no. You are now going to take these two linear equations that you have formulated. The first one, which we are given as 2x plus y is equal to 10. Remember, we are given this originally here. And this one that we formulated here, which is of what? Of 2x minus y is equal to 4. So by having your equation like this, you are now working with a simple equation that you can just solve direct. Yes, you are going to win if you use this concept, but it was going to be a lot of things. All right, so anyways, at this stage, let us eliminate x. How can we eliminate x? We are just going to simply subtract these two. Okay, the second equation from the first equation. So let us subtract, guys, and see what you're going to have. 2 minus 2, that's a 0 here. Then we've got y minus, that's a positive. So that's y plus y, which is 2y. 10 minus 4, which is going to give us a 6. All right, so divide by 2. Here, divide by 2 both sides, divide by 2 both sides, so we can cancel. Y is going to be equal to 3. All right, so that's the value of y, which is 3. Let us take this value of y that we got. We substitute into any of one of these equations. You can choose the first one, the second one, whatever. But in place of y here, we are going to substitute a 3. So that means 2x plus 3 is equal to 10. 2x is equal to 3 to this side is going to be a minus 3. So 10 minus 3, that is 7. Divide by 2 both sides, divide by 2 both sides. So that's x, which is equal to 2 into 7, that's 3. Remember 1 over 2. So that's 3.5 or 3.5, whatever that you're going to have there. But that is the idea, guys. That is what we had, and that is what we're going to. So as you can see, guys, these are typical questions that you're supposed to get used to revise along the lines so that you can minimize a lot of working in exam. All right, so that was it, guys, the stages and so forth. All right, then number 24, we are given to calculate PR from this right angle triangle using as much of the information given below as is necessary, just like what we did on that previous question that we did there, if you still remember, guys, the application of those solving triangles that we did, the application of the angles, not solving as actually solving triangles, but we're given such a condition. Where was that question now? All right, here, like this one that we did on this part. So it's just a normal thing like what we did. As you can see, it's just a repetition that we were given here. So let us see how we were going to have this one. All right, now this issue of going back now is going to give us a lot. Okay, anyways, we can understand from this idea that we did previously. All right, so that means here to calculate PR, let us see what we have got here. This is our P here, and this is your R. So according to this angle of 60 degrees, this 5 is actually adjacent. We've got 90 and the angle like that. So this is your adjacent and your hypotenuse, which is your PR. So which ratio uses adjacent and hypotenuse from your SOHCAHTOA? So remember your SOHCAHTOA here. All right. So I'm not going to, all right, let me finish up. Okay, it's fine. So this is our cos here, that has got adjacent and hypotenuse here, adjacent, hypotenuse. So that is the cos. So which means from our cos, we are saying cos of theta is equal to adjacent over hypotenuse. So that is cos theta, which is this angle of 60 degrees. So it's cos 60 degrees is equal to the adjacent now, the one that we are given, which is 5. So this is 5 over the hypotenuse, which is this one that you want to calculate, which is your PR. So take note, you're asked to calculate PR in this case. So this is PR, which is our hypotenuse. All right, so how can we calculate now the value of PR? So as you can see, guys, we have to cross multiply and so forth so that we can actually get rid of this. So cross multiply this side, cross multiply that side. It's going to be PR cos 60. All right, so this is PR cos 60 degrees, which is equal to 1 times 5, that is 5. All right, so let us put in our information. We want to calculate PR, so you can just divide by cos 60 before we substitute our information. So just divide by cos 60 by cos 60 here. All right, so this is going to cancel each other. So PR in this case is going to be 5 over cos 60. All right, so that's where now we have this information that we are given here. Cos 60 is 0.55, just like what we were given previously. I told you these zeros after the comma, do not use them. Just take this value 0.5. All right, so it's going to be 5 over 0.5. All right, so as you can see, guys, we are dealing with a decimal and we have to introduce at low numbers here. So we're going to multiply by 1 decimal place, which is 10 over 10. All right, so multiplying by 10, that's 5 times 10, which is a 50 over 0.5 times 10, simply moving 1 comma to the right, which is 5. So you can reduce 5 into 5, that's 1 into 0, that's 10. So our PR in this case was going to be 10 centimeters. All right, so that was it, guys. For this PR, it was going to be 10 centimeters, just like that. All right, so these are most equations that you can actually work with in your exams. Yeah, they ask these questions. Okay, the B part, solve the equation. Guys, look at these questions. How they're asking these questions. Okay, anyways, let us solve the first part. 0.2 n is equal to 5. So how do you find n? Just divide by 0.2, just like that. Divide by 0.2, both sides, you are done by 0.2. So n is equal to, just like what we did from the previous question, we have to get rid of what? The denominator, 1 decimal place. So multiply by 10 over 10. So if you multiply by 10 here, this is going to be 5 times 10, which is 50 over 0.2 times 10, simply move 1 comma to the right, which is 2. And if we divide this 2 into 50, which is 25. All right, so that is the value of n. That was 25. And the other equation on item 2, so this was our item 1. And item 2, we are given now to solve for m. So it's going to be a third of m. Transpose first this 2 to the other side of the equation is going to be a negative 2. So it's 8 minus 2, which is 6. So this is over 1. So you can just cross multiply, guys, as usual. So which means the 1 is going to multiply here. The 3 is going to multiply that side. Okay, so if you multiply this by 1, that's 1 times 1m, which is m. is equal to 3 times 6, which is 18, like that. So that is the value of m. So as you can see, guys, it was just a matter of what? Cross multiplication, substituting the values that you are given, just like that, you're done. All right, let's see. Question 25. Question 25, we are given, in this case, that's a velocity time graph that we had. The graph shows part of a velocity time graph of a moving object. The object starts at a constant velocity v, so which means we started at v for 10 seconds and then accelerates uniformly until it reaches the speed of 15 meters, which is the velocity in 4 seconds. Okay, so the first part is the distance traveled during the first 10 seconds, which is this one. This is your first 10 seconds here, is 50 meters. So you are given the distance that was traveled in between this first 10 seconds, which means you are working with what? With this rectangle here. The distance was 50 meters. That is area under the graph. Okay, so the question is now calculate V. All right, so guys, we know that distance is area under the graph. All right, that's what you know. And we are given this a rectangle. We know that length times width, that's our area. So we know the length is from this point 0 to 10. That is what you're going to have in this case. So it's 10 times the width, which is in this case the breadth, or the width, which is in this case, that's the height, this one, which is the V. So if we multiply this to V, we were supposed to obtain the area, which is in this case the distance of 50 meters. So that is what we had. All right, so if it was that condition, therefore, what is going to be the value of what? The value of V. So it's just a matter of now applying your equations, because we said this is equal to 50 here. All right, so you can divide by 10 both sides. You can divide by 10 both sides here. So 10 and 10 can cancel. That means V is equal to this, and this can cancel. So our V is 5 meters per second. Take note, its velocity, which is measured in meters per second. Yes, we are given. So make sure the units are actually exact the way that we are given. All right, so that was it, guys. As you can see now from this paper, I don't know what happened. It just gave us the part A. The other part is not there from our PDF. As you can see, it now jumps on to the paper 2. So, but that was what we had, guys, from this question paper, which was from the November 2007 paper 1. So as you can see, guys, this is what is very, very, very important to not understand the questions that you're given, and that can help you to revise as much as we can. And for the revision of the online classes, make sure that you just get in touch from our numbers, which is plus 27, which is 864. That's 4043. Okay, so this is 4043. All right, that's what you're going to have. So make sure that's what you're going to have. So make sure, guys, if there is anything that is there, we can actually talk. Okay, so that's what we have, guys. For anything on the comment section, let me know the areas that we can actually work on or to revise on, that it can actually help us as we are moving towards the exams, which are actually ahead of time. We actually do not have time that is left. It's actually few time that is left. So let us know, guys, the areas of focus that we can actually focus on as we are revising. But for now, that is it, guys, from Mason African Motives. Till we meet again.